Good morning, everyone. Welcome to the fourth lecture of atomic structure. My name is Suman Singh. So, let's start. As you have, I hope all of you have seen the last three lectures. So, in that lecture, what we have discussed was the discovery of electron, proton, and neutron. After that, we have seen the J.J. Thomson Planck Potting model and Rutherford alpha scattering experiment and the drawback of Rutherford alpha scattering experiment. So now we will learn the Bohr atomic model, because there was a drawback in Rutherford experiment. So we will learn now the Bohr model of atom. So before learning Bohr model of atom, we have to know some of the basic terms which will help us to know the Bohr model of atom. So two development played a major role in the formation of Bohr model of atom. The two major formation was dual nature of electromagnetic radiations and experimental result regarding the atomic spectra, which could be explained only by using quantized energy level in atom. So these are the two uh, formulations of Bohr model which play the very major role in the formulation of Bohr model. So one by one we will look at what is the mm, dual nature of electromagnetic radiations. So before starting electromagnetic radiations, we will start with what is wave. Okay, what is wave? As you can see, wave. So I will give you one example. Where, I hope all of you have thrown stone in the river or in the pond. So whenever we throw a stone, suppose stone, this is a river, this area, suppose this is the area is a river, or this is a pond, and when we throw a stone here, what we will see, like this wave is generating, right? Like this when something is going forward, no? So that is what, that is a wave. Okay, so how we can define wave? A wave can be described as a disturbance that travels through a medium or a space, transporting energy from one location to another location. Okay, I hope all of you have understood what is wave. Okay, so now wave, this wave is of two types. One is mechanical wave and one is non-mechanical waves. Okay, so whenever we are talking about mechanical waves, so mechanical waves required, in this way you can easily identify, mechanical waves always required a medium to propagate. Okay, if there is no medium, then mechanical wave will not travel, just like the sound wave. Sound always required a propagation to always required a medium to propagate. We all know that if in a room, if we create a vacuum in a room, then we will not be able to hear our sound. So we all know that sound always required a medium to propagate. In this way, the mechanical waves always required medium to propagate. Now, whenever we are talking about non-mechanical waves, so when we are talking about non-mechanical waves, so these non-mechanical waves will not require any medium to propagate. Okay, these non-mechanical waves will not require any medium to propagate, just like this cosmic rays, x-rays, gamma rays, x-rays, ultraviolet rays, infrared rays, microwaves, or radio waves, or long range wave. Okay, so these are the waves which does not require any medium to propagate. Why? Because you have seen the sun rays. Sun rays is also what, this is non-mechanical wave, because it reaches to the earth without any medium. We all know that outside the earth there is no air, no anything is not there. And then also they are propagating and reaching the earth surface, because they doesn't require any medium to propagate. Okay, So wave is of two type, one is mechanical wave and non-mechanical wave. So we will learn here non-mechanical waves, which is also called electromagnetic waves or electromagnetic radiations. Okay, so what is electromagnetic radiation? So we can easily identify what you see the word electromagnetic radiation or electromagnetic wave. It is made up of two words. You can see here, one is electro word, another one is medium word. Okay, so we can say like this: when an electrically charged particle, okay, when an electrically charged particle move under acceleration, okay, when an electrically charged particle move under acceleration, alternating electric and magnetic field are produced and transmitted. Okay, when and magnet electrically charged particle move under acceleration, and alternating electrical and magnetical field are produced and transmitted. These fields are transmitted in the form of wave called electromagnetic waves. Okay, so what are electromagnetic wave? We can easily understand with this diagram. Okay, you can see here, if you are considering this red one as electrical wave. Okay, electrical means we can say that electric field, and this one blue one is suppose magnetic field. So you can easily see that electric field and magnetic field are what, perpendicular to each other. How you can identify? Because you can easily see here that this one is which axis, this is x axis, y axis, and this one is what, z axis, and this one is x axis. Okay, you can now, I will draw it nicely. You can see here like this, like this. Okay, so in this axis, if you are, if suppose, if in this axis, y axis, along y axis, if there is like this is there, this is electric field, then magnetic field is like this along z axis. Okay, so in this way the electromagnetic radiation used to propagate. So what we can say here, if this one is electric field, this one is magnetic field. Okay, then electrical component, magnetic component and direction of propagation waves are mutually perpendicular to each other. How? One is along this axis, one is this axis, and where the wave is moving along x axis. Okay, so this is electromagnetic radiation. So electromagnetic radiation always, you can say that it is an electrically charged particle move under acceleration. Okay, alternating electric and magnetic field are produced, as you can see here. Alternating electric and magnetic field are produced, and this field are transmitted in the form of wave, which is called electromagnetic wave. And the electrical component, magnetical component, and the direction, you can see the direction, this direction, so this direction of propagation are perpendicular to each other. So this was all about electromagnetic wave. Now we will see some of the terms regarding this electromagnetic radiation, which is written here. You can also see that, you can read that one, features. So what are their features? One by one we will recall that. First feature is that they never deviate in electric and magnetic field. Okay, they used to electromagnetic, whatever the electromagnetic radiations is there, they will never deviate in electric and magnetic field. Number two, they do not have any charge. Means they are not just like, it is not like that it is carrying positive charge, negative charge, like that. They do not have any charge. And their velocity, if we are talking about the velocity, you can see here their velocity is independent of the source, which is 3 into 10 to the power 8 meter per second, you can see here. Okay, and when they propagate, it generate electric and magnetic field. You can see like this. Suppose it is propagating here, when it is propagating in this direction, they will generate electric and magnetic field. Okay, so with this conclusion, we can conclude one thing. What is that thing? Is now we will see some of the terms. After that we will see that. So what are the terms? See here, wavelength. Wavelength is what? It is denoted by lambda. You can see like this, lambda. It is denoted by lambda. So what is wavelength? It is the distance between the two successive crust and the trough. You can see. I will give you one example how it is. Suppose this is our. So if it is like this, one wave is like this, and the wave is like this, and the third wave is like this. Okay. So this length, the length between this and this is our lambda. Okay, or you can say like this, the length between this and this is our lambda. Okay, so this is the wavelength. I hope this thing you have learned in your junior classes 9, 10. Okay, and this is the unit. The SI unit of wavelength is meter. Okay, now after this we have seen frequency. Frequency is what? Frequency is what we can say number of wave which passes through a particular point in 1 second. Means what? In a particular time, how much wave is passing, that is called what? You can say like this, in a number of, suppose this is the point here, and in this point how much wave is passing through it in 1 second will be the frequency, and it is denoted by mu. Okay, it is denoted by mu like this, and its SI unit is hertz. You can say here SI unit is, you can see here its SI unit is hertz. Okay, so now this you have known. Now when we're talking about velocity, so you all know about what is velocity. The distance traveled by the wave in 1 second is called velocity, or we can also say that the speed of light is what? C. What we can denote speed of light with C is denoted by C is equal to mu lambda. Okay, are you getting or not? C is equal to mu lambda. Okay, now one more thing what we can write, since mu, this one, frequency, is inversely proportional to 1 by lambda. Okay, so now after this, wave number. When we are talking about the wave number is just nothing but it is denoted by like this. It is denoted by mu bar like this, and it is equal to 1 by lambda. Okay, all of you have understood? Wave number is what? Number of waves per unit length, means it is mu is equal to 1 by lambda. Mu bar we can write like in one more time, mu bar is equal to 1 by lambda. Okay, so this was about amplitude. Now this was about wave number. When we are talking about amplitude, so amplitude, what is that amplitude? Okay, before that you can see the formula which I have written on here. It is written here also. You can see that C is equal to mu lambda. Okay, now when we are talking about amplitude is what? The highest of the crust or a trough, or depth of the trough. Means what? You can write, you can see like this. This is our, so if it is like this, like this, like this, and like this, the amplitude will be what? This one, that is, this distance will be the amplitude, or we can say that this distance will be the amplitude, or this distance will be the amplitude, or this distance will be the amplitude. I hope you know that. Now amplitude also determine the strength or the intensity or the brightness of the radiation. If one more thing you keep in mind, that amplitude, because of the amplitude we can determine the strength or intensity or the brightness of the radiation. Okay, this one you keep in mind. After that, time period is what? It is the time taken by the wave for one complete cycle or vibrations. Okay, you can see here it is written now. So this was all about the electromagnetic radiations and electromagnetic wave, what we can say. But the particle, what we say, particle nature of electromagnetic radiation, when we are talking about the particle nature of electromagnetic radiation, before that we will learn about something about the spectrum. So what is a spectrum? It is the arrangement of different type of electromagnetic radiation in an order of their increasing wavelength and decreasing frequency. Okay, so we can say like this: spectrum is what? It is nothing but an arrangement. Okay, you can see here, if you will see nicely here, you can see that, if you will see nicely, you can see that as we are going, you can see here, as we are going this side from here to here, our lambda is increasing. Okay, and in this direction, if you are going, if you will see, our mu, which is frequency, is decreasing, and since frequency is decreasing, then energy will also decrease. You can see here it is written clearly, here to here, when we are going here, this lambda is increasing. If lambda in wavelength is increasing, then definitely the frequency will decrease and the energy will also decrease. So electromagnetic spectrum is nothing but arrangement of different type of electromagnetic radiations. You can see that electromagnetic radiations, just like cosmic rays, gamma rays, x-rays, ultraviolet rays, visible rays, infrared, microwave, radio wave, and long range wave. Now in between this, there is a visible range, and that visible range is, you can see here, 3800 Armstrong to 7600 Armstrong, in between this. Because in sometimes in the exam they used to ask, what is the visible range, tell me the visible range from where to where it is. So we can easily tell 3800 Armstrong to 7300 Armstrong. So from why it is called visible range? Because whatever the light whose wavelength is between these two numbers, okay, these two numbers, whose wavelength is between these two numbers, okay, that light we can easily, that light is detected with our eyes. Okay, that light is detected with our eyes, that is why we are called, that is a visible region. Okay, and that visible region is composed of 7 colors. You can say that: violet, indigo, blue, green, yellow, orange, and red. Okay, so this was about the spectrum. Okay, now next, so when we are talking about, when we have, now we have learned about electromagnetic radiations and spectrum and that wavelength, frequency, amplitude, everything. Now one thing, how, which because when we see the phenomenon such as diffraction or interference, can explain only the wave nature of electromagnetic radiation. Okay, diffraction or interference. Electromagnetic wave theory was successful in explaining the properties of light such as interference and diffraction. You can see here, this electromagnetic radiation, whatever the theory it is given, whatever the electromagnetic wave theory, it was successful in explaining the wave, it was successful in explaining the properties of interference and diffraction. Okay, so what we will just look at the small, I will give a small idea about interference and diffraction. So diffraction is what you can easily identify. Suppose you have seen, this is a wall, suppose this is a wall. Okay, and the water is coming from this wall. In this wall, if there is a small hole, if there is a small hole like this, if there is a small hole, then what we will see, we will see a wave will generate, water will flow like this, no? From this side to this side, this side to this side, this side to this side. This is called what? Diffraction. Okay, once again I will tell you. Suppose this is a wall, this is a wall, and in this wall there is a small hole like this. There is a small hole. Okay, so when the water will come from here, you can see that they will flow like this, no? Right? They will flow like this. So that is called a wave bends around both edges. You can see that here also it is bending and here also it is bending. Okay, a wave bend around both the edges of the small opening, forming a semi-circular wave. Forming, you can see the semicircular wave is forming. That is called diffraction. Okay, a wave bends around both the edges of the small opening, forming a semicircle wave called diffraction. I hope you have understood this. Now, interference. So interference, when we talk about interference are of two type. One is constructive interference and another one is destructive interference. So it is very easy, you can easily identify which one is constructive and which one is destructive. Suppose one wave is like this. One wave is like this. It is flowing like this. Okay, and another wave is just same as it is as this, and these two combining, and it is this two, the two are combining and making like this. These two are combining and making a big like this. Okay, they are becoming more, means we can say that the height of the trough is increasing. So that type is called constructive, and that type of interference is called constructive interference. And if it is a destructive interference, it will cancel out, because one wave will travel, suppose it is traveling like this, and another wave will exactly in the opposite direction like this, then they both will cancel out, and this type of interference is called destructive interference. But in constructive interference, it will be like this. One wave is like this and another wave is like this, and these two are combining to form one big one like this. Okay, so this is the difference between constructive and destructive interference. So electromagnetic radiations, or we consider electromagnetic wave theory, was successful in explaining the properties of light such as interference and diffraction, but it could not explain the black body radiations. Okay, moreover it cannot explain the photoelectric effect. As you can see here, it cannot explain the black body radiations, it cannot explain the photoelectric effect, and the change of heat capacity of a solid as a function of temperature. Okay, and after that line spectrum of hydrogen. So this thing they could not explain. So we will learn what is black body radiation and what is photoelectric effect, and before that we will see the Planck quantum theory also. Now, as we know, when we are going to start, now we are going to start the black body radiations. Okay, so what is black body radiations? So simply we can understand like this. Whenever there is a, how we can see, suppose we are wearing a red t-shirt, or we are wearing a black t-shirt or white t-shirt. So why that t-shirt, or why that shirt is appearing red in color or blue in color, or that white in color? Why? Because whatever the light is falling on that t-shirt, it is absorbing all light except one. If it is not absorbing blue color, then that t-shirt, that blue color is reflecting back. So that is why we can tell that that t-shirt is of blue color. Now next, if it is red, means what? All the wavelength it is absorbing, only red it cannot absorb red, then it is reflected, reflecting the red. So we said it that the t-shirt is red in color. I hope you are understanding. If we are wearing a black, if we are wearing a black, means what? Whatever the um, light, or whatever the this one VIVGOR, it's falling on the that t-shirt, on a black t-shirt, it is absorbing all the wavelength. Okay, if it is absorbing all the wavelength, means that is why it is showing black. Are you understanding or not? So how we can define black body radiation? We can define like this. A black body radiation An object emit electromagnetic radiation over a wide range of wavelength when hidden. Okay. Now, like regarding the black body, what we can say, the ideal body which emit or absorb. Okay, an ideal body either absorb